Good morning, afternoon. How y'all doing today? Welcome back to Miss Moore's Math Corner. All right, guys. Today we will be talking about dividing monomials. Remember that a monomial is simply a one-term polynomial. A lot of times we get confused with that. Polynomials are just one or more monomials. And a monomial is just one term. So, quotient rule, guys. For the quotient rule here, guys, we got a to the m power divided by a to the n power is a to the m minus n. What is happening? What's happening is when you divide the same base, you keep the base and add the exponents. Sometimes, guys, you have the a and b inside of a parenthesis already. And then in this case, guys, when you raise a power to a power, very similar to multiplication, you're going to distribute that. There's an invisible exponent of 1. You're going to distribute that exponent to everything, giving you that. That's the division rule, okay? Pretty simple. Now, sometimes you're going to get negative exponents, and when you get negative exponents, that's a bad thing, guys. We can't have that. So when you have a negative exponent, and that exponent is negative, and it's in the numerator, you are literally going to be bringing it down to the denominator. Literally. If that makes you get a little bit confused, do this. Put a 1 underneath there. That way you know clearly it's in the numerator. When you have a negative exponent, not a negative integer. If you have a negative 5 in the numerator, you keep it there. That's a negative 5. But if you have a 5 to the negative 1 power, then you make it positive. Now, you can also have a negative exponent in the denominator. And if you have it in the denominator, then you literally take that exponent and move it up to the numerator to make it positive. And then one nice pro tip here, guys, is this bad boy right here. For this bad boy, we got ab to the negative n power. You have two choices. You can distribute this, and then that will become a to the negative n over b to the negative n. And then this guy, the b to the negative n, goes to the numerator, becoming positive n. This a to the negative n goes down to the denominator, becoming a to the n. You could do that. Not a darn thing wrong with that. Or, here's the pro tip. Instead of doing all of that and then having to reverse it anyway, go ahead and literally flip the inside and change the sign. Now be very careful. When you flip the inside, you do not change any signs inside. You don't change any exponent signs, you don't change any integer signs. You just literally, whatever was on the bottom, goes to the top. Whatever was on the top, goes to the bottom. Does that make sense?
Yes.
Okay. And then last but not least, definition of zero exponent. Guys, anything to the 0 power is 1. Anything to the 0 power is 1. Those are the rules. Now let's get to it. Okay, let's simplify each expression. Okay, guys. Now I'm going to show you Modal's method, okay? Because I personally don't use the actual technical mathematical way to do this. I do, but in a different method. The mathematical way, for someone who's learning this and they're just doing it very technical, they don't have the nuances of doing it yet, they're going to go like this. 6 to the 8 minus 3 is 6 to the 5th, and that is absolutely spectacular. A modal hopefully is going to blow you away now. Guys, how many 6's do you have up here at the top?
8.
How many 6's do you have down here in the denominator? 3. Guys, can I get rid of 3 6's from here and 3 from here, and I'm left with 6 to the 5th power? No sweat. Here, I got 6 to the 3rd divided by 6 to the 8th. The real technical way is 6 to the 3rd minus 8, which is 6 to the negative 5, which is 1 over 6 to the 5th power. That's beautiful. That's delicious. That's spectacular. That's correct. However, what about this, brothers? How many 6's do I have at the top?
3.
How many do I have at the bottom?
8.
Guys, what if I get rid of 3 6's from here, leaving me with a 1? and I get rid of 3 6s from these 8 6s, won't I just be left with 5 downstairs already, and I'm done? I just blew you away, didn't I? Oh, no, I didn't. I was hoping. Does that make sense?
Yeah.
Who said no? Oh, oh, yeah. Okay. May I continue, brothers?
Yes.
So, guys, I'm going to do it like this always. X to the 5th divided by x squared. Well, I got 2 down here. Whoa, that was weird. I got 2 down here. I got to get rid of 2 here. So I'm left with x cubed in the numerator. No stress. Okay, now we're getting numbers involved. Cool. Let's reduce like always. Chapter 1 skill. 5 goes into 25 5 times. 5 goes into 15 3 times. There are 9 x's in the numerator. There are 6 x's in the denominator. Take 6 away from the denominator. Take 6 away from the numerator. And my brothers, you're done. Does that make sense, guys? If you need me to repeat it, let me know, guys. You're the boss. Okay. We got y over 3 squared. Well, I'm going to distribute. This is a power rule. I'm going to distribute that power of 2 to every exponent in here, giving me y squared over 3 squared, which is y squared over 9. Negative 2y squared over z cubed x. I'm going to literally, I'm raising this whole entity to a power. So I'm going to literally put a 1 here and a 1 here so I don't forget. And I'm going to distribute the 2 to all the exponents. So negative 2 squared, remember, negative 2 squared. Y to the 4th, z to the 6th, x squared, and that's going to equal 4 y to the 4th, z to the 6th, x squared. My brothers, this one throws everyone for a loop. What do you think the answer is here for 5y to the 0 power? Wrong. It's 5. 0, this exponent of 0, remember what I talked to you guys about in chapter 2. It only affects the number immediately or the variable immediately to its left or everything inside of parentheses. So for h, the 0 affects both of these. It affects everything. So then that would be 1 straight up. Does that make sense, my brother?
Yes.
Questions, comments, concerns, problems, issues, dilemmas so far? Let's do it. Simplify each expression. 2 to the negative 3rd power. This is 1 over 2 to the 3rd, which is 1 over 8. Sir, how do you know if it's the numerator or denominator? Look at the number, no sarcasm. If it's just a number, guys, and it helps you, put the invisible 1 of the denominator there. That way you know that 2 to the negative 3 is in the numerator, and I got to bring it down to the denominator and make it positive. All right, now I got negative 2 to the negative 3rd power. This is great. Is the negative 3 affecting the negative 2, or just the 2?
The 2.
Just the 2. So this negative, it stays up top over 2 to the 3rd, which would be negative 1/8. Talk to me, brothers. All right. May I continue?
Yes.
Okay. 4 to the negative 1 is 1/4. Plus 2 to the negative 3rd is 1/8. How did you get that, Mono? Think about it. Well, 4 to the negative 1. So I make it positive, so I bring it down to the denominator. And then I got 2 to the negative 3rd is really 1 over 2 cubed, which is 1 over 8. Common denominator, that goes to an 8, that goes to a 2. 3/8, my brothers. I got y to the negative 5th. Awesome. That's in the numerator, so I got to make it positive, so I bring it down to the denominator. Negative y, though, is being raised to the negative 5th power this time. So then that's 1 over negative y to the 5th, which will equal 1 over negative y to the 5th. Because remember, whenever you raise a negative to an odd power, it stays negative. Now for f, the answer is going to be the same, but in a different way. For f, you have negative 1 times y to the negative 5th power. So this is a negative 1 over y to the 5th power. At the end of the day, though, both of these are equal. You just got to understand and pay attention what I did that was different. In E, remember, the negative y was included, so the negative y got shifted down. And then it just happened to be negative because a negative raised to the 5th power is a negative. But in F, the 1 stayed isolated at the numerator. Okay, guys? Yeah. Okay. Now, I have negative x cubed over 4 to the negative 2 power. Me personally, I'm going to flip the inside and then change the sign of the power. So this is going to become negative 4 over x squared raised to the 2nd power. What did you do, Moro? I literally flipped, no change in sign. But when I flip everything inside, I can change the outside exponent. And now I have negative 4 squared, which is 16, over x to the 4th, because I distribute that to everything. Negative 4x to the 4th divided by 3 raised to the negative 3 power. I'm going to flip it to make the outside exponent positive, and then I'm going to distribute the outside exponent to all the inside exponents. So negative 3 cubed is negative 27. Over 4 cubed is 64. X to the 4th raised to, 3rd power is x to the 12th. Not too bad, right, guys? Okay, now, last but not least, let's wrap it all up. How the heck do we do these? Well, very simple. First, guys, go number to number, then variable to variable. So 27 and 18. I'm going to reduce by 9. So it's going to become negative 3 halves. I'm done with the numbers. That's it. I don't even worry about them anymore. Now, I got a to the 7 over a to the negative 2. Guys, let me show you the technical way, and then let me show you what Moto would do. The technical way is a to the 7 minus a negative 2. Because remember, when you're dividing, you're subtracting the exponent. So this is 7 minus a negative 2, so that's going to be a to the 9th power. And then for this guy, you got to go b to the negative 6 minus 2, which is b to the negative 8, which then equals 1 over b to the 8. So a lot of work involved. Easy work, but a lot of work involved. Let's try to mitigate that work. Let's try to mitigate it. Me personally, remember what I told you guys. I always like to make negatives, exponents a positive. So what I'm going to do is I'm going to first take these and bring it up. If I bring it up, does that become a squared? What's a to the 7th times a squared? A to the 9th, no stress. This b to the negative 6, if I bring it down, does that become b to the positive 6? Times b squared would be b to the 8th, and you got half the work there. Actually, probably like 80% less work there. For B, a lot of people are going to say, oh, we got to distribute. No, brothers. You got a monomial and a monomial. So, guys, we are going to have to use some old skills. Yes, sir?
Cancel.
You're the best. That's exactly what I was going to say. Cross reduce. So the number part, that's negative 18. Done. What's a cubed times a to the negative 4th? When you multiply, you add the exponents. A to the negative 1. And then b to the negative 2 times b to the 5th. When you multiply the same base, you add the exponents. That's b cubed. So then my final answer will be negative 18. B cubed over a. Why, Moto? Because I have to bring down that negative exponent. That makes sense? Yes, no, maybe kind of sort of.
Yes.
Promise?
Yes.
Okay. Oh boy, what do you do, Moto? No stress. This is a monomial, and this is a monomial. I'm not raising to any powers, so I'm just straight up multiplying. Well, brothers, I'm going to cross-reduce just like my boy said earlier. 2 and a 2, bye-bye. Negative times a negative, bye-bye. 5 goes into 5 one time, it goes into 15 3 times. So all of that turned into 3. M to the negative 2 times n is m to the negative 1. And n to the negative 1 times n to the 0 is n to the negative 1. I can't have negative exponents, so this is going to be 3 over m n. Okay, does that make sense, boys?
Yes.
All right, now, we have this polynomial, this little division here, raised to a negative 2. You know that we just talked about the fact that we can flip inside. But do you see, guys, how I have an a and a b both in the numerator and the denominator, and I have numbers that I can reduce inside of this parentheses?
Yes.
Always clean up the insides first. Always reduce the insides first, then worry about the powers. Trust me. So what am I talking about? Well, 5 goes into 25 5 times, it goes into 10 2 times, so I have 5 halves. A to the negative 2 over a. Remember what I said? Let's make those negative exponents positive. So let's bring the a to the negative 2 down. So a to the first times a squared would be a cubed. Good job. And then it's b to the negative 1. I'm going to bring it up. So I have a b times a b that I just brought up, and that's b squared. And that's to the negative 2 power. All I did was clean it up. Now, let's use the pro tip. Let's flip and change the outside exponent. So flip and change the outside exponent. So now that's going to be 4a to the 6th over 25b to the 4th. Why, Moto? Because I distributed the exponent to every exponent inside. Make sense?
Yes.
Easier than you had anticipated, guys?
Please excuse the interruption. This is just a test. This is a test. Thank you very much.
Okay. And then E. Oh my God, Moto. That looks so complicated. Yeah. But it's not so bad. Don't stress. First, guys, let's try to clean up everything that we have. Okay? So it's going to be 6d over c squared. Why, Moto? Because I have that negative exponent, I got to bring it down. In the next parentheses, what can I clean up here, guys?
You can move the c down.
Yes! First of all, let's move that c to the negative 3 down. Beautiful, sir.
And you could move the, add the d.
That's right. You can simplify the d's. I forgot the 2 here. I put the 2, my c cubed. Okay, yeah, I have a d down here. I take away 1 d from here. So now I have d cubed, and that's being raised to a 3rd power. Do you see that all I did in that first step was clean it up? All I did was clean it up, guys. You with me?
Yes. Yeah.
Now, let's multiply. 2 goes into 6 3 times. 3 times 3 is 9. D times d. Oh! Moto, F, bad moto. What did I do wrong, guys? I didn't follow order of operations, Moto. Practice what you preach, Moto. So this is 6d over c squared times 3 cubed is 27. D cubed raised to the 3rd power is d to the 9th over 2 to the 3rd power, which is 8, c to the 9th. Now, cross reduce. 2 goes into 8 4 times. 2 goes into 6 3 times. 3 times 27 is 81 over 4. All I did was take care of my numbers. Now I have a d times a d to the 9th, which is d to the 10th. And then I have a c squared times c to the 9th, which is c to the 11th. Yes, no, maybe kind of sort of.
Yes.
And then last but not least, well, I have 3p raised to the negative 1 power, so I'm just going to go ahead and flip that and make that to the positive first power. And then my next polynomial here, I'm going to clean this up. I'm going to take that negative p to the negative 2 power and bring it down. When I bring it down, I'm combining p cubed times p squared. Excellent, so I have p to the 5th down here, and I have a negative 6 here squared. So then I have 1 over 3p to the 8th times 36 p to the 10th, which will equal 36 divided by 3, that's 12, over p to the 18th. That makes sense?
Yeah.
Does anyone have any questions on that, guys? Because I know that we're starting to get into, good stuff here. Questions? All right, brothers. Thank you. Excellent. Hope you all learned a lot. Have a good day.